It's amazing how little has changed over the last 25 years. I mean, there are still people walking around with like clipboards and like a pen, like writing on paper, like numbers and actually doing like ink signatures. I mean, it's 2020. Like, why are we still doing things this way? Well, the answer to that question is not that simple. I mean, it's not just because there's a lack of funds or because there's a resistance to change. There's technical reasons why we're still doing things that way. We're going to talk about that and about how we can get around some of that. So, first of all, we kind of need to set the stage in terms of like how are things currently done. So, uh, we have a couple elements here we're going to be talking about. The edge, we have particle counters, osmometers, pH. That's our devices. We've got our cluster, which is really just our platform running on some servers. Could be on-prem, could be in the cloud. So for this discussion, it doesn't really matter. Database, same thing. Also, our ecosystem. Now, our ecosystem is anything external to this kind of core platform, right? So it's GLIMS, or it could be like a business reporting tool, but it's just an integration point. So how are things done today? The way we do things today is we connect our particle counter to our platform, and then we create a workflow. This is a one-off workflow specific to particle counters. We connect it to our database, and we also have a database table that's specific to particle counters and that workflow. So, this actually works great. It's very straightforward. It's relatively simple to kind of tie into your ecosystem, and this is the way things have been done for a long time. And if you have a small number of devices, works great. But we don't have a small number of devices. We have a lot of devices. So we have our osmometer, we have a pH meter, and now we have to create more, workflows, and we also have to create more tables. And this is still not too bad, but it's starting to get more complicated. It takes more time to implement, and it's more difficult to maintain. But things start to get really ugly when you have your pH conductivity meter. Well, now it's not just one thing. We have we connect it in here. Do we just modify the third workflow, or are we going to create a fourth workflow? Same thing with the database. Are we going to modify the third or create a fourth? So this is the beginning of the end. I mean, because this, once you multiply this out times the number of actual devices that you have, this just becomes unsustainable. Both from an operational standpoint. I mean, the amount of labor that's required to maintain a system like this is awful. And then it's also just the performance is no good either, because you're just going to end up with a lot of bottlenecks in a system like this. So how do we solve this? Well, the way a lot of people are solving this today is they just don't do it. They say, well, too expensive, takes too much time. It's just not worth it. It's not worth it for the technical folks. It's not worth it for the business folks. It just doesn't happen. I mean, really, most places we're doing some level of automation. We still connect a few devices to a few workflows. That can be done. So, but how do we actually realize value that all this huge missed opportunity? So the way we do that today is first we need to start with a flexible data model, because that's going to solve this problem of connecting to all these different devices. So our flexible data model leads to a flexible workflow system. Flexible workflow system means we don't need a kind of handcrafted, rigid workflow for each one of our devices. So that simplifies that. Now, our database is the same way. We're going to use a much more flexible data model that also extends to our database. So now we don't need a table for every single device. This is a much more IoT, time series way of storing and interacting with data. So now this really simplifies everything. So now we're connecting things, and it's not so much effort and labor and time and cost. So that makes this so much easier. Now we can create a workflow for pH. It doesn't matter if this is a pH conductivity meter. It just matters that it has the necessary pH features for me to run this workflow. Much simpler. Also, because these are now customizable, they're very simple, but still customizable. Different countries have different requirements. They have different regulations. They also have different sites have different cultures. People just like to work a slightly different way, and so you can now accommodate your operators. So this solves a lot of problems, but this is enough just right here. But this isn't really where things end. This is just the beginning. It's the foundation. So the next step is what we call regenerative engineering. So regenerative engineering means that we're bringing this data back out to the edge. So what's an immediate purpose of doing this? I mean, the first most easy example is you have a particle counter that's running a batch. So it's running a series of samples over a period of time, and you lose connectivity. And so in a traditional setting, what that would mean is because we can't send commands from the platform anymore, everything just stops working. But because we're going to move the workflow back out to the edge, that means this doesn't have to stop because the workflow is there. So it can just finish its job here, and then it can just kind of store and forward the data on when the connection is reestablished. So that gives a whole different level of resiliency and performance, because the resiliency because it can operate without a connection, but also the performance because we're not just hammering the cluster with all of our requests. All you do is basically pass a job of sorts out with a workflow, and it handles it on the edge. So there's a huge benefit both in performance and resiliency when we do things this way. But there are other opportunities. So one is you have other devices you don't typically interact with. So let's say you have a filtration system. So your filtration system, that's going to be something you don't typically interact with, but it's really, this data can be used to drive this, because what if it's running a lot more than it needs to? You can turn it off part of the time. Well, that saves a lot of electricity, but it's more than just electricity, because and the electricity costs are not small with these things. I mean, it can be a lot, it can be really substantial, but also because they're turned off more of the time, the maintenance and cost of replacing the thing goes down. That can sometimes be more than the electricity itself. So really, it's about more than energy. Now, this is where regenerative engineering gets really exciting, because not only do we have localized automation, not only do we have new forms of connectivity, we can start correlating data amongst these different devices because it's a unified system. So you can actually get more value out of each one of these devices that you already have. And that's a huge part of regenerative engineering. So another thing, once this is all in place, you're realizing a lot of value. Another benefit is that because we are implementing all of this at the edge, that means we're cleaning up our data at the edge, because it has to be. It can't go into a flexible format until it's already cleaned up. That flexible format is also AI friendly. So that means that once it hits the database, it's not like you have to transform it and fiddle with it and spend all this time to get that data ready for AI. It's already ready. So that means that you can very quickly implement these AI tools. But because it's cleaned up here, that means you can run your AI at the edge if the use case calls for it. So this is a very powerful thing, because everybody's really excited about AI. There's a lot of opportunity there, but most people can't even get their hands around their data. And when they can, the data requires so much kind of massaging and cleanup that it's, you spend more time actually cleaning up your data than you do doing any analysis. So, so this is a huge benefit to regenerative engineering. So at the end of the day, the purpose of regenerative engineering is to ease the implementation, to create something flexible so you can rapidly connect to all these different devices, and you don't have to worry about all of this customization, down the pipe here. So that's going to make your implementation people very, very happy. So your workflows are going to be flexible and resilient. That's going to make your operators happy. Your database is going to be full of much more data that's over a longer period of time and of higher quality. That's going to make your regulatory people and your business people happy. And that's really what regenerative engineering is all about. It's about achieving more value with the assets you already have.